And before I start, I want to tell you that for the past year, I've been kind of working with the program team on this, meetings sometimes every week, sometimes twice a week, and the amount of work it takes to put on this type of an event is amazing, and these people are amazing. So my talk today is, they have done it again. And notice there's an asterisk in front of the word it, so you can replace that with any two letters you want to do. I want to dedicate this particular talk to Alan Turing. Most of you know a little bit about him. He was a war hero of World War II, helped to decode the German Enigma code, and is credited with saving the lives of 14 million people and cutting 2 years off of the war. Now, I'm also going to take this opportunity to remind all of you that we have a drawing raffle of types for various prizes. And I wanted to make you aware that one of the prizes is this Monopoly game, because Alan Turing loved Monopoly, although he wasn't very good at playing it. And the son of his mentor devised a board of Monopoly just for Alan Turing, and they used it, and then it was lost for a number of years. And in 2012, they found it again in the attic of his son, of the son of his mentor. And they was contributed to the Computer Museum in Bletchley Park. And they said, well, gee, we'd like to turn this into a real Monopoly game. And Milton Bradley said, well, you know, we'd have to sell at least 1,000 copies to make it worthwhile. And Google said, okay, we'll buy them. And Google bought 1,000 of these, contributed them to the Bletchley Park Museum. I happened to have visited there right after that. I purchased this in 2012. It is still in the box, still in the shrink wrap, never been used, and is part of our raffle. In addition to that, there's a deck of playing cards. Now, these playing cards are 27 years old. They were produced in 1994 on the 25th anniversary of the Unix operating system. And on these cards are the faces of some of the people who helped to develop Unix. These cards were made by the Unix Association. I've had them for the last 27 years, still in the wrapper, still in the box. And you have faces in there of Ken Thompson, Dennis Ritchie, Steve Bourne, Rob Pike, Doug McElroy, and other people. No, I am not in here. I wish I was. They lamented that they didn't do a canasta deck, which would have doubled the number of people they could have honored. So, to Alan Turing, to Alan Turing, there he is. So who am I? I'm somebody who is in the right place at the right time and sometimes made the right decisions. Had a long range of different things I've done, and I'm proud of most of them. So up front, I'm going to tell you that this talk is made up of observations that I've made. Most of them are based on facts, and some of them are based on opinions, but most of them I think are true, and your mileage may vary. And later on, during the happy hour, I can give you many real-life examples of what I'm going to talk about over beer. I also want to plug the Old Farts Barf Tonight at 9 o'clock. It's something along the lines of, why did this happen? Why did we do it this way? And what does it make any difference? And we hope to have both old farts and young whippersnappers there to exchange ideas and things like that. So let's go back in time a little bit to the time before 1986, where open source and free software, in fact, software of all types, could not be copyrighted. You couldn't copyright or patent software. And that changed in the time frame of games coming in, because game manufacturers would develop a game ROM, put it on the board, and their competitors would come in, copy the board, copy the game ROM, and be able to undersell them in price. And so the game manufacturers went to the US government and said, we need to have copyright on these ROMs. And later on, they said we need to have copyright on the code, the source code that made the ROMs. And believe me, there was lots of arguments back and forth. And so copyright happened. And then when copyright happened, you had to be able to license the software. And that's where the licensing that we have came into being. Now, for a certain type of software product, like a university, they wanted to give away their software for free. And when you're giving something away for free, you can't spend $1 million on every copy trying to protect it. So they decided that they were going to have a permissive license, MIT, BSD. Take our software, use it for anything you want, but just make sure that we sometimes get attribution in certain places and things like that. And so all of the licenses that we consider to be open source came from that. With one kind of exception, this is called the restrictive license because it restricts people from using the code unless they're going to make the source code available to the end user. And this is where the GPL came in and the LGPL, the concept of copyleft as a play on words to copyright. And this is the one that Microsoft considered to be viral, okay, like a virus. And especially Steve Ballmer, he liked to call it viral and virus. And he sounded a little bit like a baying jackass penguin. And there is a prize in the raffle of penguin feet on a canvas that was done by the Jackass Penguins at a penguin exhibit and contributed by Beth Lynn. And that's part of the raffle also. So I want to give you a little background behind that. The Jackass Penguin lives in South Africa and actually does make kind of a baying sound when it sings. So that's why it got its name. Now, Steve Ballmer thought of this as a restrictive license. I happen to think of it as a liberating license because when you say free software, in the United States we have this problem with the word free. We have this problem with the word freedom. So I'm going to extend this a little bit and say that when you have freedom, you have control over your life. You can do what you want to do. Nobody else can tell you what to do. That is freedom, okay? And this is what free software gives you. It gives you control of your software, control of your computer, control of your business. And I could go on for hours on this, but we don't have the time to do that because I'm going to tell you why Microsoft is screwing up again. So what is Microsoft doing again? They're obsoleting a version of their operating system and making you make choices about whether you continue to use your hardware or not. We'll go into why they're doing that. But I'd like to point back that this is a little bit like Windows XP, where millions of people were still using Windows XP and they just decided that, nope, we're not going to put out any more bug fixes on that. We're not going to allow people to continue using it. And we're going to see in a little bit how bad that really was and is. So they're isolated. They're forcing people to go to Windows 11, which doesn't support various types of hardware that people are using. And these people may not be able to afford to simply go out and buy a new system that will support Windows 11. And then Microsoft says, oh, just upgrade to Windows 11. And there's lots of reasons why you don't want to do that. Mainly you figure it isn't broken. It's perfectly okay. But it will be broken because sooner or later there's going to be you're going to try and have to get a new piece of hardware to fit in that old operating system and the device driver is not going to be available for it. Or you're going to have some type of bug happen that you haven't detected before. Or you're going to have some type of security hole that's been found that you haven't been aware of before and you're going to need a patch for it. So you can't just sit there because when you sit there, in fact, the software works backwards. And even if all of that wasn't true, upgrading is disruptive to you. It's disrupting to your business. It's disruptive to your users. They have to go. And typically, there's no budget for it. This is sprung upon you, and you have to make a decision sooner or later what you're going to do. But why does Microsoft want you to upgrade? Well, it's easy. Even though they're a very large company, they have lots of people working for them, not everybody is a software developer. Now, Microsoft has about 200,000 employees, but not all of those bear the title of software engineer. Some people are product managers, some people are sales support people. Some people put software into boxes. Some people take software out of boxes. Some people work in the cafeteria. Some people paint lines on the parking lot outside. And when you really look at the number of people that have said software engineer in Microsoft, it's 100,000 people. Still sounds like a lot. However, only 47,000 of those 100,000 are developers, and it's spread across a whole wide range of different products. So when you find out that there's actually only one person still working on Windows, I'm saying it's more than one person, 2 people, maybe 3, that, you know, they want to take those people and put them onto the next operating system. They don't want to be supporting this old broken down operating system called Windows 10 for the rest of their lives. So, how many open source developers do we have? Well, there's lots of different ways of measuring this, but according to IDC, which a lot of people look at, they see there's 5 million full-time open source developers, and 7 million part-time developers, and 7 million people that don't get paid at all for developing software, but they just happen to like it, okay? And granted that there's huge numbers of open source projects, but not all of them have people even working on them. They got to a certain level, they have a declared in fact bug-free, there's no more bugs. All they have to do is be recompiled every once in a while, and they go on. And, you know, and people do cross work. Some people support 3, 4, 5, or 6 different software projects at one time. So it's hard to imagine this, but I've been using, in effect, the same text editor for over 50 years. E, ED, EX, VI, and Vim, okay? And I looked at supporting Emacs, but I didn't want to have an operating system as my text editor. But some people like it, so I'm not gonna go against them. And the other thing you have to ask is, why are these Microsoft engineers doing their programming? Do you really believe that a Microsoft engineer who works on Microsoft Office actually uses Microsoft Office that much? I mean, they're a software engineer. They probably haven't written a text document in their entire lives. And how many of them actually use every feature of Microsoft Office? My God! They only probably use about 10 features, and all the rest of them they've been supporting over the years because people asked for them one time. And by the time they got around to giving them that feature, it was too late. That person had died. So there's, 90% of Microsoft Office is probably only used by 2% of the people, if that. So why do open source people start projects? They start them typically because they say, hey, I need this for my own work. And I find a bunch of other people who are in the same boat. We all work together, but we're using the product because otherwise we wouldn't have started it. We're not selling it. We're not starting it to sell necessarily. We're starting it because we need it. If you take a look at things like Blender. Blender started up as being a closed source proprietary product. They went out of business. And when they started selling off the intellectual property, the users of Blender liked it so much, they bought the intellectual property and then set up the Blender organization as a nonprofit organization to keep it going. They loved Blender. They wanted Blender to succeed. And this is the type of thing that happens in the free software space. Now, one of the other things you're going to hear about in open source and closed source discussions is the security of software. And some people say that closed source is more secure because you can't see the source code, so you can't see the holes in it, so therefore you get security through obscurity. On the other side, the open source people say, well, many eyes see the issues. You got all these people that can see the software and they can find holes and fix them before people see them. And I call crap on both of these. Because I used to work for Digital Equipment Corporation, I used to see pieces of software that only one engineer ever worked in that software, only one engineer ever saw it, and sometimes that person died, okay? And on the other side, I see open source projects that only have one person working on them, so there's not many eyes, okay? And neither one of these have any meaning at all. You want to know why? Because the most important thing is the fact that when you find the problem, you can fix it. This is called mean time to fix. And mean time to fix is the most important thing in security. That when you find out that there's a hole, you get it fixed quickly and on every machine you have. Not just that you have the software working on Intel and it's fixed on Intel, but what happens if it's not fixed on ARM or one of the others and your operating system or your other software works on that? You need to have it fixed all the way along the line, and you do that with source code. Now, I will give you a real life history about this. I worked for DEC. We had an operating system called Ultrix. It had come to end of life. DEC actually sold off the intellectual property to a small company that had like 4 engineers, and they were supposed to fix bugs and stuff like that. And then along came the Morris worm. How many of you are old enough to remember the Morris worm? Ah, yes, just swept through Unix systems, just knocking them down right and left, you know. And my management fixed it on digital Unix at the time that ran on the Alpha, but they refused to fix it on Ultrix. And I knew that there were thousands of Ultrix systems still out there running it, and they were just dying right and left. And I had to blackmail my management into creating the fix for that and get it out. But we still had to get the engineer in there. We had to get the engineer to understand the problem. We had to get the engineer to generate the patch. We had to test the patch. And so it took us 3 weeks to get that patch out to our customers. And in the meantime, their systems were dropping like flies. How long did it take the open source community to find the problem and fix it? 3 days. 3 days to get the source code patch out there so that people could fix their system. No, I'm sorry, it wasn't 3 days, it was 3 hours! 3 hours! And they got the open source patch out there and people could apply it to their systems. And this is why InfoWeek magazine, for 3 years in a row, gave the prize for the best customer service, not to Hewlett Packard or IBM or Digital or Sun or any of those others. They gave it to the open source community. And after that, they stopped giving out the prize because they knew the open source community was going to win it every time. But before we talk about Windows 11, I'm going to remind you the concept of promises. We all live in the United States, most of us, some people from Canada. And we have had deals and promises that we've given to Native Americans that were good as long as the grass shall grow and the water shall flow, which usually lasted 2 or 3 days. And so this is why people say, well, I buy my software from big companies like DEC and Compaq, and they'll always be around. You know, the companies like Enron and Kodak and Sears. I have a Sears refrigerator. I have a Sears vacuum cleaner. Good luck in getting replacement parts. You know, and sometimes even if the company is still in place, they have product lines and they wipe out product lines. I won't say anything against a company called Google, but, you know, we've all, I think, experienced some times where Google said, oh, we were just kidding about that. It was just a test case. So how much can you trust these companies to keep going and stuff like that? So you have to balance the cost of taking control of yourself, your software and things like that, versus the cost of trusting people who may have good intentions. I mean, I don't think companies go in to business with the concept of, with the thought of we're going to go bankrupt in 3 years, unless of course you're some of the financial institutions we work with. So, but on the other hand, a lot of people don't have, they say, well, I don't have the experience or the knowledge or the people to be able to create this trusted system. Well, maybe you don't. But maybe you have a community of people who do. And maybe you can help to support that community of people by buying services from them and stuff like that, instead of spending your money in useless licenses from companies that are not as good at it. And so if you had an operating system that was obsolescent by the company that made it, if they released the source code, you might be able to form a community around those people to maintain that into the future. And maybe companies and banks and government institutions would join in on that to give that operating system a longer life. Oh, and there's also the concept, I mean, Microsoft sets up these areas, these buildings, where if you want to look at the source code for their operating systems and their products, you can go to this building. You're not allowed to take cameras, you're not allowed to take notebooks, you're not allowed to take phones, you're not even allowed to take a pen and pencil, but you're allowed to look over the internet and see the source code for their operating system. Now, if you believe that the source code you're looking at is the source code that generated the operating system that you're using, I have a bridge to sell you in New York City. And you're going to have to fight off a whole bunch of cheap politicians who want to sell you that. So let's talk about Windows XP, my favorite, next to VISTA. It was retired in 2009, but there's hundreds of millions of systems at that time that were still running Windows XP. And the only time that Microsoft veered away from its generating patches for that was with the Spectre Meltdown issue in 2018. And that was so horrible and so egregious that they actually broke their own policy and generated the patch for that. But what else didn't they patch at that time? There was lots of other bugs and lots of other security holes that were less likely to be, so they didn't patch them. Now today, people estimate that 0.6% of all the desktop and laptop PCs that ran XP are still running XP. And 0.6% doesn't sound like a lot, but if you think about the fact that there were 2 billion desktops and laptops and stuff running Windows XP, that means that there's 12 million still running it. And yes, they're run behind firewalls and other types of protective stuff, but they're still out there. And some of them are still being used by banks. And some of them are still being used by our military. Doesn't that scare you? It scares the shit out of me. And there's one country in Eastern Europe who actually has 60% of the systems in that country are running Windows XP. So, let's remind ourselves that Spectre and Meltdown was so horrible that even Microsoft had to create that patch. But what is the major reason given for Windows 11 breaking hardware? Because it will. That major reason is security. We want to make it more secure. And to be fair, if I'm ever fair to Microsoft, we have the boot code, which is going to be UEFI, the Unified Extensible Firmware Interface, which will replace the 40-year-old BIOS, which needs replacing. I will admit, that's good. And it will allow you to implement secure boot. That's also good, where you'll be able to say, I trust this operating system that's on my trusted piece of hardware, and the operating system has to trust the applications that are going on it, and up the line, you can create that long list of trust. That's good. The part that's bad is that the certificates for that trust are only coming from one vendor, and we can all guess who that is. We don't have to guess. We know. It's Microsoft. Now there's ways that you can get an application that will be signed, so will be able to be booted, and that application can pass off the trust to the next operating system that's going to run. That's fine. But why not use an open source version of UEFI that you don't have to do that? And maybe you get some other certification agency to do that. Why can't we do that? I don't know. So Windows 11 allows the secure boot, but implements that through UEFI. But that's only part of it, because there's this other little thing called TPM. It's a chip that has complete control over your operating system, and your data can go anywhere and do anything. And it's used for security, and it's used for applications to be able to boot systems, even when you think they're off, you can still boot them if you know the right magic, okay? And those two, or the lack of those two things, are going to limit the hardware that Windows 11 will work on. And Microsoft says, well, just run Windows 10. And eventually you'll buy some new hardware which will have these capabilities. But they're still running Windows XP. So now we're going to go a little bit beyond that. We're going to talk about the issues of binary blobs. Most of you know what binary blobs are. They're things of binary objects you can't get the source code to, you can't figure out how you made it, you can't reproduce it. It comes from people who write device drivers and people who write accelerators like GPUs and stuff like that, and people who write boot code. And they have these pieces of your operating system that you can't look at, you can't figure out what it is, what it's doing. And then you go down a level. What's below the operating system? Well, it's the CPU and the GPU. And you have two basic types of that. You have complicated instruction set computers known as CISC. That's best represented by Intel and AMD, where every single machine language instruction that you can see is actually hundreds or even thousands of these tiny little instructions called microcode. And you don't know what they're doing. You don't know what type of exceptions are happening inside the system. You don't know that maybe a trapdoor is actually generated inside of that. You can't see it. But then compare that to RISC, reduced instruction set computers, where every single instruction is one instruction. And yes, the electronics is doing something inside. You can't see what it is, but it's a very simple thing. And you can time it, and you can try it to see if it's been monkeyed with. And you can investigate where that chip. And beyond that, there's a new RISC chip coming out called RISC-V, RISC-V. And that's an open architecture that's being worked on by many different people to define a new instruction set, a new architecture for computers to simplify and to learn from the stuff where we made mistakes for the last 50 years, and we're still paying for them. We're still carrying those mistakes forward. And they're now beginning to create chips that are very simple, have the minimum of instructions to run an operating system, and then extensions for acceleration, extensions for other things, but you don't have to have those just to run Linux. You can just deal with the instructions in what they call the core instruction set, a handful of instructions. What else does this do? It means that the processor itself can be very small on the piece of silicon, that one piece of silicon can actually make 5 times or 10 times as many processors as an Intel chip could. Because the Intel chips are massive. They have to have all this crap that nobody ever needs, but they have to carry it along just in case somebody wants to. And so you can follow this. It's an open architecture. You don't have to pay any money to license it. And people have actually created RISC-V processors by using emulation. They've used RISC-V processors by using FPGAs. We'll get to that in a moment. And people have used their own, they've gotten access to fab plans through things like the Skywater plan that's supported by Google, where people have designed RISC-V chips and then are able to actually have them put on a piece of silicon through this program. Now, you say, my God, I can barely understand what the operating system does. What about a chip? Why should I not trust Intel? Well, first of all, they put the stupid TPM thing there. That was one thing why you shouldn't trust them. But the second reason is we live in a wonderful country called the United States. I love the United States. My rights are protected by the Constitution, except for one thing. It's called the Patriot Act. And if I talk to somebody outside of the United States, I could be a terrorist, and people could listen to me. Now, we'll get to this in a moment, but just imagine, start to think about, what if you live outside the United States now? And this is more than just a CPU, it's the GPU too. That GPU is a little program that, works on huge amounts of data, doing a single thing to it across the board. It's sophisticated. It can hide stuff. The software drivers for it can hide stuff if they're binary blobs. And the USB is the same way, and the Ethernet's the same way, and your SATA disk controller is the same way. They can all hide things from you in the hardware. And a possible replacement for all this is to use something called a field programmable gate array. Now the word gate relates to something, it's a transistor. The word transistor and gate are almost interchangeable. Two transistors make a flip-flop. Two flip-flops make a half-adder. Two half-adders make a full-adder. A bunch of full-adders in a row make a register. A bunch of registers make, and a control unit make a CPU. So it all comes down to a gate, a transistor. And what a field programmable gate array is an array of gates, an array of transistors, which you can reconfigure in the field programmable gate array. And one moment, the field programmable gate array could be a CPU like RISC-V, and in the next moment, a field programmable gate array could be a GPU. You just give it a different program. And what this means is you now have control completely over the hardware and the software in your system with no binary blobs. Now, if you people think that this is an impossible thing to do, well, the University of Sao Paulo, one time I went down there, was upset because GPU makers were not making a lot of open source GPUs, not telling us how to program them. And I complained to the professor at the University of Sao Paulo, embedded systems, you don't need a powerful GPU. You just need something to do a little bit of work, very simple. I mean, the whole thing could be replaced by an FPGA. He looked at me kind of strange. He said, "You're right." And 6 months later, 2 graduate students had created a field programmable virtual GPU that could run the entire OpenGL test suite and all of the codecs that GPUs normally work with. 6 months. And it was fast, even in emulation. So the next step is to take the emulation part and put it into a real FPGA and make it available. And all of this work that they did is up on GitHub. It's all freely available for people to use. And we could use the FPGA to replace the GPU. So you can do all sorts of interesting things when that happens. Now, Linux and Unix always was more secure than a lot of other operating systems. Because while MS-DOS was a single user system that came out before the internet was reaching into people's homes and offices and businesses, it was a single user system. You didn't even have to log in. You didn't even have a password. But Unix was always a time-sharing system, even from version 1. And so it had to be built with the concept of security in it. Now, it's not perfect, of course. There's lots of things we can add to it to make it better. But it was way more better than the original personal computer operating systems. And again, I know this is not the only operating system that came from this, and had these capabilities. Certainly BSD also did. But it's something to build on. And so if we take a look at all the solutions that we have for Linux that are available to our fingers, we have things like encryption. Now, a lot of people will tell you that encryption, especially politicians, will tell you that encryption is evil. And I will point out to them, I'm sorry, but encryption is the basis of authentication. And if you don't know who you're talking to, you can make a big problem. So you need good encryption and you need good authentication. And I would periodically write 4 or 5 page letters in fine print to various politicians who were trying to create laws in the United States to eliminate encryption, as if they could. We've also had GPG as a long-running example of that. And we have other open source encryption capabilities. And if people think that obscurity is the only way to keep encryption good, that's exactly the opposite. You need to make encryption so secure that you can publish every single line of code that makes it up, and it still is mathematically impossible to break it that way. That's when you have a good encryption technique. And we need to teach people how to use encryption. We should encourage them to use it all the time. Encrypt everything. Encrypt your lunch menu. Encrypt your mail you send to different people. Encrypt your file system. Why should we be doing this? Because then the powers that be that want to spy on us, they want to look at our personal communications, are going to have to go back the way they did it before. They're going to have some reason to look at you. They're going to have some reason to go to a court and get a search warrant or get a subpoena from a judge that then they come to you and they say, we have to decrypt this. You have to show us this decrypted thing. It's not something they're going to do in the background, behind your back, okay? And the thing is, although every encryption technique is breakable through brute force, and with, some of the newer, faster computers coming out, they're going to be able to decrypt things. If you encrypted everything, they wouldn't know what to decrypt. And so they'd be right back where they started again, right? It's not clear text anymore. So what do we have with Linux? Well, you can encrypt an entire file system, or you can encrypt individual files if you want to. There's many different programs for doing encryption. You also have things like Linux pluggable authentication modules, PAM. The same thing that was used in Unix, re-implemented with Linux and free software, allows you to authenticate individual users to run individual programs, sometimes on a time basis. You can only run this program from 9 to 5, Monday through Friday. You can't access it any other time. You can mount this file system during these time frames. Otherwise, it's kind of invisible. You don't see it. You don't have to modify the source code of the program to do this. You can just do this through the tables in the Linux system. There are also some GNU Linux systems that are more secure than others. There's some that specialize in security, like SCLinux. Originally started by NSA. Oh my God, the people we're trying to protect ourselves again are helping us create the secure system. Yes, because they too need a secure system. And they helped us design it, and Red Hat supports it as a basis of their system. AppArmor is another that does the same type of security on an application-by-application basis, and that's used by SUSE Ubuntu and is turned on by default in Debian 10 and beyond. You also want to be able to limit destruction, because in this day and age of ransomware, all of us, whether we have money or not, are liable to be hit by ransomware. And it creates huge amounts of damage. Now, you can set up, if you really want to work at this, you can do things like set up jails, so that people try and break into your system, they think they're in your system, but they're really not. Honeypots are another example of this, where you can keep people busy trying to think that they're destroying your system, but they're not. You can set up containers and virtual machines to protect your system too. We have all of these capabilities that are available if you know how to use them, and if you want to go through the steps of using them. We have Samba to allow you to share files across different operating systems, stuff like that. And there's whole distributions that specialize in security. Systems that block your IP address from being seen by other people. Systems that allow you to test your own system to see if it's secure. And so you can make your system really, really secure. Here's a thought. If you have a gateway or if you have a firewall, why not use a non-used CPU a lot? Why use an Intel CPU for that? Why not an ARM? Why not a RISC-V? Because if somebody's going to create a program and they expect it to run on that system, they're going to be surprised. They're going to try and have their Intel-based application working on your RISC-V based system, and it just is not going to work. So these are all things you can do to make your system and your systems of systems more secure. You also should try and configure your systems for what you're doing to a minimum standard. The more application software you put on a system, the more likely it is that somebody's going to get access to it through a bug. So set it up for a specific thing to do, and that's how much software you should have on there. Start to use IPv6 addresses. 128 bits of address. Typically, the upper 64 bits are used by the ISP, and they give you the lower 64 bits to work with it. So you can spread all of the systems in your environment amongst those 4 billion times 4 billion addresses. And so if somebody's trying to brute force log into your system, they're going to have to go through the 4 billion, or at least half, on average, of the 4 billion times 4 billion addresses. It could take them a long time. They'll probably get tired and go some other place. If you really want to frustrate them, every once in a while you switch the addresses around. And don't also remember, you can have different ports on each address. And so you can really screw them over. Here's something I found interesting. Recently, I had a friend of mine from Brazil, a young person, say, I want to get a two-factor authentication key, but they're really expensive down here. I want to buy 2 of them, that'd be $150. And so I never really put much attention into this before, but I said to him, aren't there any open two-factor authentication keys? And one search of the internet, one line search, found this company, Solo Keys. And they had just come out with the version 2 of their key, which is completely open hardware and open source software. They publish the circuit diagram, they publish the Gerbers for creating the PCB boards, and they publish all of the software that they use inside the system absolutely free for you to use. They're lower cost than the traditional ones that he might have bought in Brazil. And so using a key like this, along with multi-factor authentication, can make your system a lot more secure. Now, one of the other things we have in our little contest or drawing or things we have today is something called the Freedombox Pioneer. This is a little open hardware single board computer, which is made by a company called Alimex. They publish their circuit diagrams, they publish their bill of materials, they publish the Gerber files. They allow you to make their systems if you want to, but it's really cheaper if you're only buying like 1,000 to simply buy it from them. But you can see everything it does. And the hardware controllers on there are completely blobless. And attached to the bottom of that is a little docking station that they sell for €9 without a disk. I happen to have a 1 terabyte disk in here. And this is going to be part of our raffle that's online. Somebody will walk away with this hopefully tonight. If not, they can receive it by mail. Now, that would be interesting enough, except you could also use this because it runs Debian 10. You could use this as a NAS server. You could have RAID 1 set up on it, software RAID, if you wanted to. It actually has a SATA port, an eSATA port in it, so you don't have to tie down your USB ports. And it has 1 gigabyte of RAM in this particular one. Now, I have a little NAS box at home with 2 12 terabyte 3.5-inch discs in it with eSATA. And when I get back from this, I'm going to set that up because one day before I came here, I had gigabit per second fiber installed in my house up and down. So that's going to be my basis of my web server and stuff like that. But the Freedombox, just the hardware would be impressive, but the software is more impressive. Now this was created by a man named Eben Moglen, who is a law professor at Columbia University in New York. Eben was probably most famous for having written the GPL version 3. And Eben's a good old boy, and he got concerned about 12 years ago about people sending all of their most private stuff to the Google Cloud and to AWS and places like that. And he said, I think we need to have a little secure server that can plug into your outlet at home, doesn't need air conditioning, doesn't need, three-phase power, all that type of stuff. And you can put your most private of information on that. And you still send all of your cat pictures to Google. They loved them. So he got together with some people. They started a project called the Freedombox Project. And 10 years later, they came out with version 1.0 of Freedombox. It allows you to set up your own VNC server. It lets you set up your own Tor server. It allows you to set up your own web server, your own email server, things like that. And all of the software is included in Debian 10. So you don't have to buy a system from Olimex. You can just use your Debian 10 system and Debian 11, of course. Debian 11, by the way, is a long-term support release of Debian that will be good until 2026, or at least until they drop support for Windows 10. So there's a lot of functionality here, and there is a front panel on this, a dashboard on this. Doesn't make it mom and pop easy to install, but it makes it pretty easy to install, okay? So I think most of the people in this room would be very easy to install and set up a really good Freedombox. They even set it up so that you can set up your own certificate. You don't have to go to some nasty company in Redmond, Washington to do that. Now, on top of this, in the future, they're going to put federated social media. Things like Diaspora, Mastodon, GNU Social, and others. And so you'll be able to set up a distributed social network so that Mark Zuckerberg will be really upset. Okay? And you can do things like exchange ebooks and stuff like that amongst yourselves, amongst your little community. Because Freedombox is not just about a personal secure server. You can set up a community server off of it. And there's a little book on the Freedombox site that says, well, what does this mean, setting up a community server? It's very interesting reading. And along those lines, you still have the traditional things we do with Linux, firewalls, gateways, packet filtering, demilitarized zones, so you can set up a place that people can access the internet without getting into your internet. And it's just pretty amazing. But all of these things are things that you have control over because you are using Freedom software. But all of these things typically needs training. And I'm going to put in a little blatant advertisement for lpi.org, where we do certification of systems administrators, including security systems administration. But you don't have to take our tests. You can go to our website and you can see the objective of each test. You can say, yeah, I know how to do that. Yeah, I know how to do that. What in the God's name are they talking about? What's this System D thing? I don't know anything about that. Probably good, but I don't know anything about that. Maybe I should learn something about that. And if you can go all the way down that objectives list and you feel confident you can do that, then you're probably a pretty knowledgeable systems administrator. That's what you need to know. And so the bottom line of all of this is that we have to bring the control of our systems back to the users, back to the people that own the hardware, back to the people that own the system. And instead of migrating from Windows 10 to Windows 11, we need to tell them how to migrate to Linux. Because I've been using basically the same Linux system with incremental upgrades I never had to pay for ever since May of 1994 when I met Linus Torvalds. And you have to fight for the control of your hardware, and you have to fight for the control of your software. And that will be the last migration that you have to do. But you also have to train your users and your management that this is the reason you should be going there. Now, people from time to time ask me about the future, say, what is your prognosis of the future? And I say, we've always had antagonists, but now they're even worse. Because in the beginning, they were simply script kiddies. People would find these things on the internet and they would apply them against 10,000 systems, break into one, and they would tell all their friends, and then their friends would rat on them to the FBI, and then the FBI would go and arrest the 10-year-old kid. But now we have serious people. People doing ransomware, governments doing terrorism and e-terrorism. And it's only going to get worse. In fact, we have people in various countries, I won't name the countries, but you could probably think of them, who actually have set up businesses in selling software to break into other people's systems. So they don't break in themselves, they simply sell the software to these other people who will use it to break into systems. And it's only going to get worse. And then we have the really serious people, the agencies we dare not say their names. And this is where you have to think of yourself as maybe living outside the United States, because everything changes when that happens. Dilma of Brazil found out that the NSA was reading her email. She was quite upset about that. But then, even if you live inside the United States, you have other agencies. You know, when I was growing up, they were the KGB. They changed their name, but not their tactics. Now they're the FSK. And there's another type of security, supply chains. We in the United States have been shipping all of our production over to China. We have to stop that. How many of you heard of the fact that China managed to grab the major cobalt mine in the Belgian Congo after the United States, for over 50 years, poured money and stuff in there to woo the Belgian Congo people into selling us the cobalt, which will be used for making batteries for electric vehicles. And China just went in there and said, capitalism, free trade, we want to buy all your cobalt. So we have to protect our supply chains. We have to get the manufacture of chips, fabrication plants, back to the United States. And I tell every country that will listen to me, you need to secure your supply chain. If you're a small country like Monaco, you can't possibly develop everything yourself. That's okay. You make friends with your people around you, and all of you are in the same boat. And you make sure you have a supply chain. Because the days are gone where we could send something into space with a slide rule and a set of books like they had in Hidden Figures. That's gone. It's gone that we'll be able to fly planes, because if I snap my fingers like this and all of the computers disappeared off the face of the earth, planes would crash from the sky, you know, traffic lights wouldn't work, traffic would be in a mess, we couldn't pump oil, we couldn't pump gas, everything would just fall apart. And now we can do that at 1 billion cycles a second. So what keeps me awake at night? Bad beer and scotch. Bad scotch. Fortunately, I got some good whiskey from the OLF people. But what really keeps me awake at night is Internet of Things and infrastructure. And Internet of Things is terrifying. It's already bad. It's going to be mega bad, okay? Unless we build the security into it, and unless we make sure that we are in control of the data. Not Mark Zuckerberg. Definitely not Mark Zuckerberg. And I'm not paranoid. Because if I was paranoid, I would be thinking about things that aren't true. And my conspiracy theories are true. They've already happened. And they're continuing to happen. and I'm diabetic, and I'm fat, and I'm old, and I'll probably be dead in 10 years, but some of you still have some life left in you, and you're going to have to worry about this. I'm going to become senile soon, so I won't have to worry about it at all. It'll be your problem. And finally, a word to any Cs in the audience. That's CTOs, CIOs, all the other Cs. Stop treating your systems administrators as if they're an expense item, a necessary expense item, and treat them like the asset that they are. Listen to them so they can help you set up your system better and it'll be faster and more efficient than what you have already. Give them a voice in your company. And know that no system is completely insecure, but you can certainly frustrate the people who are trying to break into it so they go off to somebody else instead of you. Here are some references that are available. You know, you'll have access to the slides and things like that. And final little advertisement for the drawing is the quilt. This quilt is made up of 42 panels of t-shirts from my collection of 15,000 t-shirts that I've collected over the last 50 years. And the LPI actually paid for the manufacture of these t-shirt squares into this quilt. It has a very nice fleece backing, very soft. I have a king-size one in my house, and I sleep under it every night. So this is also part of the raffle online. You have all these gifts, and you also have Beth Lynn's canvas, as she says, with the penguin feet. And all of the money goes to help to support OLF, so we have more events like this next year. So thank you very, very much for attending. And I'm going to have a BOF later tonight. I have to tell you about the BOF. This is the BOF of old farts and, whippersnappers. So come there. It's just going to be a fun BOF, not any slides, no main speaker stuff. We're just going to wing out and people tell stories and stuff like that. It'll be a great time from 9 to 10. Thank you very much. Any questions? Can I answer any questions or any points that people would like to say?
Make sure you use the mic if you ask questions. We do have an online comment, John, which is apparently OnlyKey. OnlyKey.io is another security key, which is fully open source.
Yes, I didn't cover all of it. I became aware of that one a couple days ago, and I just didn't have time to work it into my talk.
Somebody have a question?
Okay, well, I'll be around for the rest of the night in the BOF and stuff like that. And you might be able to find me at the bar later on under the table.
I got a quick question.
Okay.
So you mentioned historically that it wasn't until the late 70s, early 80s that software was recognized as being copyrightable, which then obviously led to the advent of proprietary software and the open source free software movement.
No, actually, it was proprietary software before that. It was just protected with a different method, contract law.
Okay.
And
Okay.
if you didn't protect it with contract law and it got out, then it was just public domain.
Mm-hmm.
Okay.
Okay.
But do you have more part of the question?
Yeah. So my question is, do you think that we should go back to not having software be covered under copyright legally? Would you advocate for that?
So this is always a point of contention with Richard Stallman and myself. Richard Stallman didn't believe in intellectual property. He didn't believe in copyright. And I had to point out to him that without copyright, you had no way of forcing the GPL license on anybody, right?
Mm-hmm.
So without copyright, his GPL was worthless. And people would have just taken the code that somebody made visible, change it, create a binary, and he wouldn't have had nothing, nothing he could have done to stop that. So I do believe in copyright. I do believe in intellectual property. I do believe in the economic business of making free software. Now, one thing that Richard and I always agreed on is that you should be able to sell free software. And you should be able to make money from it. It's just that the total economic model says you can't sell it for a huge amount of money, just rape people over the coals, because if you do that, somebody will fork the software and offer it for less money. So I think there's a little company, you may have heard of them, called Red Hat. They've been very successful at selling free software. And when I first started programming, my mother came to me and she said, "John, what do you do for a living?" And I tried to explain to her how I was writing these ones and zeros and instructions and stuff that would tell a computer what to do. And she would say, "Never mind." And then years later, I actually gave them a PC. And believe it or not, it ran Windows. I think it was Windows XP when it first came out. Because I'm a pragmatic person. I knew that the people around my mother and father only used Windows, would be able to help them if they got into a thing. And I lived 10 hours away, and I was not going to be able to be their support person. So after she used it for a little while, I came to visit. She says, "John," she says, "I finally think I know what you do. You write the programs that we use on our computer." I says, "Well, Ma, I used to do that like 30 years ago. But now I'm using GNU Linux. So right now, basically what I do is I sell free software." She thought about that for a little while and she said, "Never mind." Did I answer your question?
Yeah, I have a follow-up one if that's all right.
Okay. I'm perfectly happy.
So it sounds like you are saying that obviously the GPL would not be enforceable if copyright law did not exist. It does not sound like you're saying that you think that proprietary software should be allowed. Do you think that the GPL should be codified into law? Obviously, this is hypothetical.
I don't believe in a mandate that says how you obtain your software. Okay? I believe in educating people as to the advantages of using free software and encouraging them to use free software. Just as like I don't really like open source, because open source is great for the developer. You get access to all this source code and you say, "Oh yeah, this is great. I cut down my development time. I have much more stable software, stuff like that, because it's used in other places, da 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 da." However, you can still create a binary-only distribution for your customer, and they're still in the same boat as if it was Microsoft or Oracle or Apple or anyone else.
Apple actually uses that concept with your iOS. It's based on BSDs,
Right.
not GPL.
Right. And so, if you're going to say that the only way you can have software is to have free software, well then you're forcing everybody, and there'll be some people who say, "I'm not going to develop software at all." So my job is to convince people of the business models of free software and that this is really the way to go. And you know something? I think I'm winning. I think we're all winning. For the number of people that generate free software and use free software and create products that are truly free. And I believe in that very strongly. And I have a whole drawer of things that were developed with open source software that they never opened up their software. The companies that produced it have gone out of business, or they stopped producing that product, and I can no longer use it because it wasn't free software. And free data. Don't forget free data. Creative Commons. Okay? We need to be able to do that too. We need to have collaboration. So if you listen to Bernie Sanders, and I'll admit I'm a Bernie boy, okay? I voted for him In 2016, I voted for him in 2012. No, I'm sorry, 2016, 2020. And I believe in his platform, and particularly what he calls democratic socialism. Because another word for democratic socialism is an employee-owned cooperative. There's lots of those in the United States. If you've ever bought Land O'Lakes butter or milk or cheese, that's a farmer's cooperative. If you're in the rural states and you have a rural electrification program, that created a lot of cooperatives. In that case, they're owned by the customers who vote every year for the management and stuff like that. There's actually a software support company down in Texas that's a cooperative. And all the people that work for it are owners of that. You see, when you're a capitalistic company, you may have the owner and the board of directors and the stockholders live 20,000 miles away from the company, from the manufacturing plant that's polluting the river, that's polluting the air, and they don't care. All they care about is making their profit. But when you're the employee and you're living right next to that river or breathing that air or having that black lung, maybe you're going to try and do something to stop that because your kids are dying of cancer. So I'm not going to tell people that they can't produce closed source software, but I'm going to tell people that what you should be buying is free software.
Thank you.
You're welcome. I'll see you at the BOF, and then maybe the BOF.
I do have one statement, maddog. Maddog. I do have one statement. I have two perfectly good laptops. When I went from 8 to 10, Microsoft wouldn't support the Wi-Fi, so they're now Linux machines. Now I have 3 PCs that won't go to Windows 11, so once they stop Windows 10, that's going to add 3 more Linux machines. So, you know, it's not a conscious decision. They're just driving me to the Linux operating system.
But there are some people that are not going to do it for all the reasons I gave you, right? It's inertia. They're afraid. They feel they can't get it. You know, I have another talk I give sometimes, the 10 reasons why you can't use Linux and the 10 reasons why those 10 reasons are crap. And for every one of those 10 reasons, I have 10 reasons why they're crap. But yet I still keep having it. It's like an urban legend. It's like a vampire. It never goes away. It's like a zombie. You kill it 10 times, it still comes up. But all we can do is keep killing it. Keep trying to kill it. Thank you again, folks.